Okay, today we're going to talk about isomerism. What are structural isomers? Well, the definition is they've got the same molecular formula, but they've got different structural formula, depending plural, singular. Okay, so let's think about some molecules that have all got the formula C5H10. Okay, so they could have, let's think of what we could have there. Right, first of all, we could have, so we've got the ratio of CN H2N, not plus 2. So that means they've either got to have a double bond or they could be cyclic. Okay, so let's do the cyclic one. So we could have cyclopentane. Okay, so I'll draw out full structure. 2 hydrogens on each one, which I should put in. Okay, or we could have, so if we draw the skeletal formula of that, which is much easier, we draw it like that. We could also have, so I'll draw a box around that. We could have 5 carbon atoms in a row. And we need to have a double bond somewhere, so let's put it there. So 2 hydrogens on that one, 1 there, so on. Forgive me for not putting the hydrogens on there. So if you wanted to draw that as a skeletal formula, we'd have 1, 2, 3, 4, 5, and then a double bond on the end. So that's another one. We could have the same thing again, but we could put the this time put the double bond in between carbons number 2 and 3. Put it there. Okay, so we draw that like that, in skeletal form. Okay, if I put the carbon double bond here, it would be the same, wouldn't it? So that's not another possibility. Or if I put it there, it would be the same as this one here. So, you know, I'm not going to do those. They're the same molecule. So what else could we have? Right, we could have we could have 4 in a row, and we could have a branch on it there. Okay, I need to put a double bond in there. Let's put that one in there. So we've got those. Sorry, there wouldn't be a hydrogen there because that would mean 5 bonds. 3 hydrogens on that, 2 on that one, and 3 on that one. So we draw that skeletally. 2, 4. Then we'd have a branch coming off there, and we'd have a double bond there. All right, just going to get rid of this bit down here. Come back to that later. That's a little sneak preview of what we're going to do the next couple of minutes. So yeah, we could have that. What other possibilities have we got? Well, we could have this one here, 4 in a row again. We could put the carbon there, but this time move the double bond, we could put it there. So there'd be 3 hydrogens on that, 3 on that, none on that carbon, 1 on that, and 3 there. Skeletal formulae, we draw it. We've got a branch there, and we've got a double bond between carbons 2 and 3 there. And I think you can probably see there's one more of these we could have. Same basic outline as this one, but we're going to put the double bond there between those 2 carbons. So I'll draw that one. I'll branch there, and we'll put the double bond there this time. So 3 hydrogens on that one, 3 on that carbon, 1 on that, 1 on that, and 2 on the N1. Draw a skeletal formula for that. We've got that there, and we have got the double bond there. Right, so you may think, all right, what about the possibility of having 3 carbons in a row with 2 sort of branches on it? Now you'd be able to see probably you can't have a double bond in that molecule. So wherever I put it, if I put it there, it means the central carbon atom is forming 5 bonds. So none of them exist. Okay, so I think that's all the isomers we've really got there. Let's have a look at those together. Right. So they've got the same molecular formula but different structural formulae. Now, what we need to do now is we need to think about subdividing them into different kinds of. We can subdivide them, okay? We could say, are they functional group isomers? Are they, then they could be chain isomers. We'll explain what this means in a minute. Or they can be positional isomers. So let's number these so we don't have to, so we call that one number 1, 2, 3, 4, 5, and 6. Now, I've got a little flow chart here, which I'll hopefully squeeze in, and might mess this up and I might have to go back, but I'll try. Okay, so we're going to use this little flow chart, okay, this one here, in green, to decide what kind of isomers have they got. Okay, so let's choose 2 of those, and I think the first 2, let's have a number 1, which is cyclopentane, and the other one, which was pent 1-ene. Okay, so let's see what kind of the structural isomers, because they're both C5H10. Now let's see, are they functional group isomers, are they chain isomers, or are they positional? Right. So the 2 molecules, looking at this bit here, the 2 molecules do have the same molecular formula, different structural formula. This question, do they have the same functional group? No, they don't have the same functional group, do they? Because this one is an alkane, if you can call that a functional group. I don't really think you do. But this has got a carbon-carbon double bond. This has got an alkene functional group in it. So no, we go to no, the next step here. So we can decide these are functional group isomers of each other. This pair of isomers are functional group isomers of each other. Right, let's choose 2 more. Let's choose, we had pent 1-ene and we had pent 2-ene. Okay, let's have a look at these 2. Right, let's go through the Let's go through the questions again, shall we? Okay, so here, do they have the same molecular formula, different structure formula? Yes. Next question, do they have the same functional group? Yes, they do. They are both alkenes, aren't they? Yeah. So the answer to that is yes. So move down to the next question. Do they have the same carbon backbone? Well, they do, because they've both got 5 in a row. They've got 1, 2, there's no branches, 5 carbons in a row. So the answer here is no, they're not chain isomers each other. So the question is, the answer here is, these must be positional isomers. Okay, so they've got the same carbon backbone, the same functional group. The only difference is that the functional group is on a different carbon atom. So they're called they're positional isomers of each other. Right, let's do another couple now. So again, when you're doing these, when you're talking about functional group, chain, or positional isomers, it's very important this of each other bit. That's under, oops, I need to do that. This of each other bit, which I'm just underlining there. It only makes sense to say things are chain isomers or positional isomers when you're talking about a pair of them. You can't just say, oh, something's a, it's always when you're comparing it to something else. Let's have a look at 2 more of those. So we have got, right, let's say that one, which would be called 2-methyl-but-1-ene, or this one, which you would call 2-methyl-but-2-ene. Okay, so let's go through the questions again. Do they have the same molecular formula? Different? Yep, they do. Do they have the same functional group? Yes, they do. So they're not functional group isomers. So we move down to the next question. Do they have the same carbon backbone? Yes, they do. So these are, again, these are positional isomers of each other. Right, let's do one last pair before we finish up. So let's have pent-1-ene, and this one here, which is 2-methyl-but-2-ene. Okay, let's look at those two. Right, go through the questions again. Do they have the same structural molecular formulae? Yes, they do. So they're some kind of isomers. Do they have the same functional group? Yes, they do. So move down to this question. Yes. Do they have the same carbon backbone? Well, the answer is no, they don't, because this one here has got 5 in a row, whereas this one has got 4 in a row with a branch off it. So these are chain isomers of each other. All right, so that's the end of that video. I'm going to do another video in a minute, which is going to be just another example of that. Get some structural isomers and subdivide them, see if they are functional group, positional, or chain. Okay.